Hello everyone, and welcome to today's presentation. I'm Dr. S.K. Singh, and I'm pleased to have you here. Today, we'll be exploring the fascinating topic of contamination sources, specifically focusing on electrostatic contamination mechanisms. Over the next few slides, we'll delve into how electrostatic charges can lead to contamination and discuss the mechanisms behind it. I look forward to sharing insights and engaging with you all during this session. Let's get started. Let's talk about electrostatic discharge, or ESD for short. This is basically a sudden transfer of charge between objects. According to ISO standards, it's defined as an electrical breakdown caused by a charge imbalance. Now, one related mechanism we should be aware of is electrostatic attraction, or ESA, which actually acts as a driver for contamination. In environments, we typically focus on controlling particles and microorganisms, but there's a hidden contamination source that often gets overlooked: electrostatic forces. Static electricity has this sneaky ability to attract, hold, and transfer contaminants, which can compromise the cleanliness and integrity of sensitive processes. Understanding ESD and electrostatic forces is crucial because they can be subtle but impactful, especially in environments where purity is paramount. Recognizing how static electricity interacts with contaminants helps us develop better strategies to keep our as contamination-free as possible. Let's talk about why electrostatic contamination really matters. Often, it's something that gets underestimated in the pharmaceutical industry, even though it can have serious consequences. But in electronics and sterile environments, it's seen as a critical factor. It's actually recognized as a major mechanism for microcontamination, which can cause a range of issues. For example, product defects can occur when electrostatic charges attract unwanted particles or microbes. These charges can also lead to microbial or particle adhesion, making contamination harder to control. And on top of that, electrostatic buildup can even cause damage to equipment over time. So, understanding and managing electrostatic contamination is essential to maintaining product quality, ensuring safety, and protecting equipment in these sensitive environments. Let's talk about the role of the cleanroom environment in electrostatic risks. Cleanrooms, while essential for maintaining a contaminant-free space, actually increase the risk of electrostatic discharge, or ESD. This is mainly because of a few key factors. First, the low humidity levels typical in cleanrooms cause the air to be dry, which makes static charges more likely to build up. Second, the high use of insulators, materials that don't easily conduct electricity, also contribute to static buildup. Third, the controlled airflow, designed to keep the environment clean, can facilitate static charge accumulation and distribution. Because of these conditions, static can build up very easily in clean environments. Now, moving on to the mechanism of electrostatic contamination. It all starts with charge generation, often through the triboelectric effect. Basically, when two materials come into contact and then separate, they exchange electrons, creating a static charge. These charges tend to accumulate on insulators, which don't dissipate the static easily. Once enough charge builds up, an electrostatic field forms around the object. This field acts like a magnet, attracting particles and microbes from the environment. These particles can then deposit onto critical surfaces, risking contamination. It's important to understand that charged surfaces act like particle magnets, pulling in dust, microbes, and other contaminants. This is why controlling static in cleanrooms is so vital for maintaining the integrity and safety of sensitive products and processes. Let's take a closer look at the sources of electrostatic charge. One common source is personnel, specifically through clothing friction. Whenever we move around or brush against surfaces, static can build up on our clothes. Plastic materials are also a significant factor because they tend to generate static charges easily, especially in certain conditions. Equipment movement is another contributor. Anytime machinery or tools are moved or operated, static can be created. Low humidity environments are particularly problematic because dry air doesn't allow static charges to dissipate quickly, leading to higher buildup. Additionally, synthetic garments are notorious for generating static charges. Wearing these types of clothing can increase the likelihood of static accumulation, which is why managing clothing choices can be important in sensitive environments. Overall, understanding these sources helps us better control static buildup and prevent potential issues, especially in settings where static discharge could cause hazards or damage. Now, let's talk about materials that can act as contamination drivers, specifically insulators. Insulators include materials like plastic, glass, and ceramics. These materials are unique because they tend to retain charge, which makes them different from conductive materials. Since they hold onto their electrical charge, they can't be grounded easily, unlike metals that quickly dissipate static. For example, a plastic tray can attract airborne particles because of its static charge. This is important to keep in mind, especially in environments where contamination control is critical. The key takeaway here is that these insulating materials can become sources of static buildup, which in turn can attract dust, dirt, or even microbial contaminants. Understanding this helps us better manage and minimize contamination risks in our processes and environments. Now, let's talk about personnel-induced contamination. One important aspect to consider is that the human body naturally generates electrostatic charge. This can happen in several ways, such as when we walk or move around. Friction from clothing also plays a significant role in building up static electricity. Interestingly, clothing can hold a charge even independently of the body, which means it can become a source of contamination on its own. For example, if someone has a charged sleeve and then comes into contact with a sterile vial, that charge can transfer and cause contamination. This highlights how critical it is to manage static and personnel movement in sterile environments to prevent contamination risks. Essentially, our own body and clothing can inadvertently become vectors for contamination if we're not careful. Let's start by looking at electrostatic particle attraction. Charged surfaces have the ability to attract a variety of particles, including dust, microorganisms, and fibers. This attraction isn't limited to just large particles. Even submicron particles, which are extremely tiny, are strongly influenced by electrostatic forces. For example, imagine a charged wafer. The particles in the environment can be drawn to its surface, leading to adhesion. This might sound harmless, but it can actually cause issues like yield loss in manufacturing processes, since contaminated surfaces can impact product quality. Now moving on to electrostatic discharge, or ESD. When a sudden discharge occurs, it can cause a lot of problems. It can damage sensitive products or components, especially in electronics. Additionally, ESD can cause surface contamination to redistribute, which can lead to further issues down the line. It can also disrupt manufacturing processes, leading to inefficiencies. Overall, ESD doesn't just pose a risk to individual components. It can affect entire production lines and the integrity of the products we're working to create. Understanding these electrostatic effects is crucial for controlling contamination and protecting sensitive technology. Let's take a closer look at some of the advanced technologies used to control electrostatic discharge. For instance, air ionizers are really effective because they neutralize charge in the air, which is especially useful in situations where grounding isn't practical or possible. Then we have ESD flooring systems and conductive materials, which help to dissipate static charges safely and efficiently. These are essential in environments where static buildup could cause damage or contamination. Another key technology is real-time electrostatic monitoring. This allows us to continuously track static levels and ensure our control measures are working effectively. For example, ionization is often used where grounding can't be implemented easily, providing an alternative way to neutralize static charges. Moving on to regulatory expectations, it's important to understand that standards like ANSI ESD S 2020 require a comprehensive ESD control program. This isn't just about having some measures in place. It involves a complete, well-managed approach. ISO 14644 emphasizes the importance of controlling environmental contamination, which directly ties into our static control strategies. And in the EU GMP Annex 1, there's a clear requirement to include ESD controls within the broader Contamination Control Strategy, or CCS. Ultimately, contamination from static can come from many sources, so controlling it thoroughly from all angles is crucial for maintaining product integrity and safety. Let's take a look at this case study to see how these issues manifest in real-world scenarios. Here, we're dealing with a semiconductor defect caused by particle contamination on wafers. This type of contamination can seriously impact manufacturing yield, leading to increased costs and delays. The root cause of this problem is electrostatic attraction, which occurs when particles are drawn to the wafers by static electricity. This static charge often results from handling processes involving plastic carriers, which can generate and hold static charges. To address this, the solution involves implementing ionization techniques to neutralize static charges and using ESD-safe materials that prevent static buildup. By doing so, we can significantly reduce particle attraction and contamination. This case highlights the importance of controlling static electricity to maintain high yields and product quality in semiconductor manufacturing. Tying back to the broader theme of static control and contamination prevention we've been discussing. Let's wrap up with some key takeaways. First, electrostatic contamination might be invisible to the naked eye, but it's absolutely critical to control in cleanroom environments. These charges can cause significant issues, especially in sensitive manufacturing processes. Electrostatic contamination works through two main mechanisms: attraction, where particles or microbes are pulled towards surfaces or objects, and discharge, which involves the sudden release of static electricity that can disrupt operations or damage products. Controlling these effects isn't just about awareness. It requires a combination of engineering solutions, like grounding and proper material selection, and procedural controls, such as staff training and handling protocols. And remember, maintaining a clean room isn't just about controlling particles and microbes. Electrostatic forces are equally important. They can influence the behavior of particles and microbes, so comprehensive control strategies are essential to ensure a truly controlled environment. This holistic approach helps us protect product quality, ensure safety, and maintain the integrity of our processes. For further support, please don't hesitate to contact us. We're here to help you with any questions or additional information you might need. Remember, we value your engagement and want to ensure you feel confident moving forward. Thank you so much for your time and attention today.